This video teaches you how to use the trace key and its usefulness. The trace key will allow you to automatically find ordered pairs anywhere along the function, specifically the intercepts or the roots of the function. It can also be used to estimate the maximum and minimum values for a polynomial function, as well as estimating the ordered pair where two functions intersect. Example number 1, y equals 2x cubed minus x squared minus 15x plus 2. We would like to find one ordered pair from quadrant 1 and quadrant 2. Then estimate the roots of the polynomial, then estimate the y-intercept, and finally estimate the maximum and minimum values. Let's input the function y equals 2x cubed minus x squared minus 15x plus 2. Okay, so the function goes up and it reaches some maximum here, then goes down, then reaches some minimum down here, and then goes up. So what we need to do is adjust the window so we can see the maximum value and the minimum value. So if we go to Window, let's decrease the y minimum to -30 and increase the y maximum to 30 and change the increments to 3. And now we'll graph it. So that looks like a good view of the function. For part 1, we wanted to find an ordered pair from quadrant 1 and quadrant 2. So here's quadrant 1 and here's quadrant 2. So we'll start out by using the trace key, and notice that the cursor is flashing right here and the cursor is flashing on this particular function. This is the function we inputted earlier. And then here are the coordinates of where the cursor is located. So we will move over to quadrant 1. So I use the right arrow to move the cursor to the right. And we're asked to find a ordered pair, so this is fine. We're in quadrant 1. So the ordered pair we can write down is 3.191 and 8.957. Now if we move to quadrant 2, that ordered pair is fine right there. So we can write down -0.638 and 10.647. Okay, so for the next part, we were asked to estimate the roots. So the roots are when this particular function is equal to 0. And where this function is equal to 0 is the intersection of the x-axis. So right here, and right here. So what we can do is let's zoom in a little bit closer on this function. So we will go to Zoom, and then let's go Zoom Box. The reason why we're going to zoom in is because the closer we are to the points of interest, in this case it's the roots, the more accurate our answers are going to be. So let's move the box to the left a little bit and then up. So let's say right there, and I'll hit enter to start forming the box. And then I'll move it to the right. And let me move it down a little further. Okay, right there. So let's hit enter. So again, the roots to this particular polynomial are right here, here, and here. So if I hit the trace button, let's move to the right. And we'll get an approximation. So about right there is good. So at 2.947 is when the function is going to be equal to 0. Now, this should be close to 0 right here. So if I move a little bit to the right, see, it increases a little bit, and if I move it one more to the left, alright, it's not quite at 0 either. So the closest I was for this being to 0 is right here. So that's not the exact answer, because this needs to be 0, but it's close enough. So like we said, we just wanted an approximation. So it looks like it's actually at 3, but this is the approximation right here, 2.947. So let's go to the next root. And that looks like about right there. That's a little bit closer right there. So at x equal 0.1 is another root. Once again, the value of x is only an approximation since y is not equal to 0. Let's go to the last root. And it looks like about right there. So let's take a look at that. So is it closer to 0 for this value or this value? And it's actually closer to 0 for this value. So the approximation for this root is negative 2.594 since the value of y is not equal to 0. Now let's find the y-intercept. That's what we were asked to find also. So let's move that to the y-intercept. Now the y-intercept is occurring about right here. So let's go ahead and zoom in on this area so we can get a little bit better picture. So let's go zoom box. So let's hit enter. And we'll move the cursor down and then to the right and down a little bit. Now we'll select enter and we'll move the cursor down and then to the right. Okay, and then enter. So there's a little bit better view of the y-intercept right there. So I'll select trace and let's move the cursor, and it looks like about right there. Now remember, the y-axis is where x will equal to 0. So that's pretty close to 0. So that would be a good estimate, 1.931. So the y-intercept is approximately 1.931. That's where it crosses the y-axis. Okay. Now let's go to zoom previous. So we'll select zoom and then we'll move over to memory, and then z previous goes back to the previous zoom. Okay. So finally we were asked to find the maximum and minimum values. So here's the maximum right here, and here's the minimum value. So let's go ahead and hit trace, and we will move to the right to get our minimum value. That's the lowest point, so that occurs about right there. Negative 16.582, about right there. Okay? So at this ordered pair, 1.793 and y being negative 16.582 is the approximation of the minimum. Now let's go to the maximum value, so let's move to the left. And the highest value for y looks about right there. So there's the highest value for y, and again, this is just an approximation. So at x equal negative 1.44, we get y equals 15.555 as our approximation of the maximum. In a future video, you will learn how to find the exact values of the maximum and minimum and the exact values for the roots. Okay? So let's go to example number 2. Okay, we will first clear out the function, and then we will go to zoom and then standard, so we'll view the graph in standard mode. And let's get out of this. Okay, so we're ready for example number 2. We would like to estimate the solution for the system of equations y equals 2/3 x subtract 7 and y equals negative 3x plus 1. So that's y equals 2 divided by 3 times x, subtract 7, and then we'll enter that to go down, and then negative 3x plus 1. And let's go ahead and graph this. So there's our intersection point, and where they intersect is where they share the same ordered pair for both of these lines, and that's going to be the solution to this system of equations. So we can zoom in on this intersection point, and that gives us a closer view of the intersection point, and it allows us to get a more accurate value when we use the trace key. So if we go zoom and then box, we hit enter, and there's the cursor flashing right there. You can just barely see it at the origin. So let's move it down a little bit to the right so you can see it better. To the right a little bit, and then we'll move it down. Okay. Now let's select enter. So we'll move it down and then to the right. And let's go a little bit over and move up. Okay, so let's select enter. So we're zoomed in very close, and let's hit trace. And you can see now that this cursor is on y1. So this linear function y1 is shown right here. Now if I hit the arrow down, the cursor jumps to y2, which is shown right here. So it doesn't matter which function the cursor is on, we can go ahead and oscillate between the two. And I always like putting it on the curve that's closest to the intersection. So that would be this curve right here, or this linear function right here. So let's move it over to the intersection point, and about right there is what it looks like. So the approximate solution for this system of equations is going to be x equals 2.187 and y is negative 5.542. Okay? So for example number 3, we would like to estimate the solution for the equation, the ln of the quantity x plus 9 subtract the ln of 2x equals 4. Okay? Now, the left-hand side of the equation that involved the ln's, we will go ahead and let that represent y1. And then the right-hand side of the equation we'll let equal to y2, and that's 4. Okay, so when we go into the input function mode, the ln of x plus 9 subtract the ln of 2x. Close the quantity. Okay, now remember that y2 is going to be the right-hand side of the equation, and that's equal to 4. So the solution for this particular equation is when the left-hand side of the equation will equal to the right-hand side of the equation, which means that when this particular curve intersects this particular curve, then that will be the solution. Okay, we're going to go zoom and then zoom standard because we want to view it in the standard viewing window. So here in the standard window, it looks as if there is no intersection point right here. It looks like the curve ln of the quantity x plus 9 subtract ln of 2x. Looks like it stops about right there. So what we'd like to do is zoom in on this particular area. So we could use the zoom in key. So we select zoom, and then number 2 is zoom in, and put the cursor right there is fine. And let's go ahead and hit enter. Okay, so we can see that the line crosses the curve about right there. So let's zoom in on this particular area. So we need to use the zoom box, because if we used zoom in again, it wouldn't show anything. It would zoom in too close and we probably wouldn't see any parts of either Y1 or Y2. So let's use zoom box. And remember, that allows you to have better control on your zooming. So let's go ahead and move the cursor right there, and we'll select enter, and we'll move down. And we'll move to the right. Okay, that's good. And we'll select enter. There's a real close-up view of the intersection. So we're interested in this value right here, so we can select trace. Okay, and if we move to the right, you can see the cursor starting to come down. And it looks like right here is as close as we can get to the intersection. If we move one to the left, hops up a little bit, and then if we move one down, so either one is pretty close for an estimate. So we use this one. And this occurs when x is approximately equal to 0.085. The value of y should equal 4. And remember, we wanted the left-hand side of the equation, which is this one, to equal 4, which is this line. So at approximately 0.085, the value of y is 4. So that's pretty close, 0.085. Alright? If I go back to the previous screen and select zoom, and then go to memory, and then zoom previous, if I use trace now, so here you can't really see the cursor. Now, this is what gets a little confusing, and that's why I'm showing you this screen. If you notice, as I move to the right, the values of y are starting to decrease. So that means the cursor is actually going down. So what I need to do is move the cursor to the left, because we want this value to be equal to 4 when we get up to here. So let's move this to the left. Sometimes when you move the cursor around, you can't actually see it, so you have to really pay attention to your coordinates and see where you're at. There it is, right there. So I'm moving it closer to the intersection, which it looks like it could be right here or possibly right there. Now remember, the previous screen, the value was 0.085. Okay, so here it says 0.05, and if I move a little bit over, it's 0.1. So that's why you need to zoom in as close as you can, and you'll get a more accurate value of the intersection point when you use the trace key. Okay, so this concludes the video on using the trace key. And remember that the trace key was very versatile. We used it to find approximations for maximum and minimum values. We used it to approximate the zeros of a function. We used it to approximate the solution for a system of equations. And we used it to solve an equation, and that was when we found the intersection. And we also found the y-intercept. Okay? In a future video, we are going to learn how to use the calc option of the calculator. And what this does, it allows us to get a more accurate answer for the roots of polynomials, the maximum and minimum values of polynomials, and the intersection for a system of equations.